Hello guys. So in this video we are going to discuss about Perceptron. Now if you don't know about Perceptron guys, it is also a very simple neural network unit. We also say Perceptron as a single layered neural network. Single layered neural network. Okay. We'll try to understand what exactly this is, and in the upcoming videos we'll also try to understand what are the advantages and disadvantages with respect to Perceptron, and why do we move towards multi-layered neural network, which is again we call it as an artificial neural network. But if I talk with respect to artificial neural network, the difference between Perceptron and ANN, I can say Perceptron is a basic unit of ANN. Okay, so in this video we are going to cover what is exactly input layer, hidden layer, weights, activation function, right? So let's take a very simple example. And if I talk with respect to Perceptron, this Perceptron, which is a single layer neural network, it is used in solving binary classifier. Okay, that basically means if my data set has a problem statement which is of a kind of binary classification, we can definitely use this Perceptron to solve it. Now over here, let me give a very quick example by taking a simple data sets. So let's say I have a data set over here. Okay, and in my data set I have features like IQ and number of study hours. Okay, number of study hours, and the output is either pass or fail. So I need to create a Perceptron which will be able to predict based on IQ and number of study hours whether the person is going to pass or fail. So let's say in my data set, I already have this particular data set where the IQ is 95, the study hours is 3, the person is going to fail. Let's say if the IQ is 110 and if the study hours is 4, the person is going to pass. And let's say if the IQ is 100 and if the study hour is 5, the person is going to pass. So let's say that I have this 3 data sets, 3 rows of data set with me. Okay. Now how this particular data set will be taken in a Perceptron and how it will be trained, that is what I'm actually going to show you. Okay, and with respect to that, we are going to discuss about all these things with respect to a Perceptron. Now this is super important guys. Please try to understand this entire flow, the entire architecture of a Perceptron. To begin with, the Perceptron will first of all have something called as input layer. Okay, so this is my 1 input and 2 input. Okay, now this we usually say it as an input layer because the number of inputs that I have is 2. So let's say over here I have x1, over here I have x2, and this is my output feature. That is the reason why I have actually created only 2 inputs in this input layer. Okay, let me again rub it and probably create it once again for you. So in my input layer, I have 2 specific inputs. Okay, super important. Okay, now this specific input, this is my x1 and this is my x2, will get passed to this. Now from here it will get connected to a simple unit of neural network. Okay, and we specifically say this layer as hidden layer. Hidden layer. And this is specifically hidden layer 1. Okay. And from here you'll be seeing that this input will be connected to this hidden layer 1. Okay, I'm basically showing you how a Perceptron is, what is the architecture, what is the diagram of a Perceptron. And I'll talk about what is this x1 or x2. I have already told you these are my inputs. It will be going one by one over here. Now in this hidden layer, I will specifically tell you that this is a neuron. Okay, neuron. I'll talk about the importance of neuron and all. And in this neuron, we specifically perform 2 tasks and then we give the output. Okay. Now, this is the diagram of a Perceptron, a very simple neural network unit. Okay. Why we say this as a single layer? This is obviously an input layer, right? We do not count an input layer as a separate layer. We just count the hidden layer. And in this hidden layer, I just have 1 neuron. Okay, 1 neuron. So this we specifically say it as a single layer neural network. Now what all operations usually happen in this? First of all, I hope you got an idea about input. Since I have 2 inputs, x1 and x2, that is IQ and number of study hours, those input will be passing it from here, right? Then the next thing that we really need to understand is about weights. Now what is weights? Let's say that when this input is getting connected to this neuron, This input is getting connected to this neuron. We initialize some weights like W1, W2. Now, what is the importance of this particular weight? Understand, guys. Let's say this is my left hand. Okay. And I'll give you a practical example to make you understand. If I keep a hot object over here, then what will happen is that those signal will get processed through my neurons and it will go to the brain saying that something hot is placed over here. So I have to remove my hand, otherwise it will harm, right? So this processing of the signal and telling my brain that something harm is going to happen, how these things are actually happening, it is all because of the neurons, which is signaling, which is processing that information, and it is telling us that, yeah, something harmful is going to happen. Now, this hot object, when I place over here, the weights are getting activated. The weights are high. And that is the reason I'm removing this particular hand, right? I'm not moving my other hand, right? I'm moving this hand because the hot object is placed over here. And this is all possible because as a human beings, right, our neurons are well trained to handle those things. So the weights will be quite higher when such kind of events happen, and those weights will make sure that our neurons gets activated in that. Okay. So this weights play a very important role, and the entire mechanism of this neural network is that we need to train these weights well, which will be able to identify different tasks for us. As a human being, if I'm seeing a camera, I'm able to identify that I'm talking in front of a camera. If I see a cat, I will be able to identify that, okay, I can see a cat. If I probably see an animal for the first time, I will not know it. But somebody will train me. Oh, this is a dog. This is a hen, right? Like that. A kid, when he or she is born, they will not know about any animals from the start. The parents will teach him, okay, this is a dog, this is a dog. Then only he'll come to know, he or she will come to know, right? So this weights will play a very important role, right? So we have discussed about weights, input layer and all, and we have also spoken about hidden layer. Now in this hidden layer, I have one hidden neuron, right? Now inside this hidden neuron, two simple processing will happen. As I said, right? I keep a hot object, some processing will happen and that signal will go to my brain, right? Which will then I will do a response to stimuli, right? Now over here, two simple steps will happen. This is step 1 and this is step 2. Okay. Now in the step 1, what will happen is that I will do the summation of x of I, w of I. That basically means I'm going to multiply the inputs and the weights, and I'm going to do the summation of all the inputs and the weights, right? So in short, if I try to denote this by z, my step 1 will be denoted by z. I'm going to perform an operation which will be like x1 w1, or let me write this as w1 x1, w1 x1 plus w2 x2. Now, since I just have two inputs, that is the reason I have written x1 and x2. Like this, I can have any number of inputs. That basically means I can have any number of features. Input is never restricted, but with respect to hidden layer, I'll just have one neuron in the perceptron. That is the reason we say it as single layered neural network, right? So in short, what we are doing? We are doing the summation of inputs multiplied by the weights. Okay, superb important, right? Now, along with this, we will also add one more parameter, which is called as bias. Okay. Now, what is exactly is this bias? Along with this inputs, I will be giving my B, that is my bias. It is been denoted by B. Okay. And let's say that I'm going to give a constant over here as 1. Now, what is the importance of this bias? So let me just add bias over here, which is like plus B. Okay. So in short, what I'll do, I will write Z is equal to summation of W of I, X of I plus B, right? So very simple operation over here, what I have actually written, okay? Or I can also write this as X of I of W of I, same thing, right? So I will basically write summation of I is equal to 1 to N, X of I, W of I plus B, right? So this is the step 1 operation. Okay. Now, what is the importance of bias? There are multiple very important things regarding bias. Let's say if my weights are randomly, usually the weights are initialized randomly initially. Let's say if the weights are initialized as 0, so no processing is going to happen. So this bias needs to have some kind of value, right? So that this entire processing will not become 0 and this hidden neuron will not become deactivated, right? Because all the output will be 0. So what we do is that we add a small bias, and this bias is treated as a noise. And this is super important because we really need to create a generalized model. Noise basically means a data that may be completely different, and our model is also able to handle those, right? In a linear regression term, we also say this as intercept. Okay, and I'll discuss about that as we go ahead. Okay, so this is basically the bias that we specifically have. Now this is what happens in the step 1. Now in the step 2, what happens is that we get this Z value. On top of Z, we apply an activation function. Now what exactly is the activation function? The main aim of the activation function is to transform the value. So here let me write it activation function, and we'll be learning about different activation function. Activation function basically transforms the output between some values. Let's say between 0 to 1 or between -1 to +1, right? If I really want something to be between 0 to 1, I may use a sigmoid activation function. So sigmoid activation function diagram also I'll try to show it to you, like how it is drawn. -1 to +1, you know, let's say if I want to make it between 0 to 1. So here I can actually use something called as a step function. Okay, so let me just draw this over here. Now how does a step function look like? So step function is also an activation function. Now step function usually diagram looks like this. Okay, so step function which looks like this. So here I have all my values between 0 to 1. Let's say this is 0, this is 1. The another one that can be applied as an activation function, there are many activation functions like ReLU and all. We'll try to understand. We'll try to understand the importance of each of this, right? So here also you can see that I'm having this sigmoid activation function which looks something like this. So my sigmoid activation function will be looking something like this. Okay, so this is between 0 to 1, right? So again, understand what is the main aim of the activation function. Since we are solving a binary classification problem, at the end of the day, right, after performing this operation, either I should be getting 0 or 1, right? So in case of step function, what we do is that we get two conditions. Okay, let's say this is my Z value. If my Z value is less than or equal to 0, I'm going to make it as 0. And if my Z value is greater than 0, I'm going to make it as 1. So in step function, my threshold value is basically 0, right? Either I need to get 0 or 1, right? So whatever Z value I'm getting, after I apply a step function on top of that, if this Z value is less than or equal to 0, it is going to become 0. Otherwise, if it is greater than 0, it is going to become 1. Right? Similarly, in the case of sigmoid activation function, if my Z value is greater than 0.5, it will become 1. If it is less than or equal to 0.5, it is going to become 0 because this is 0.5, right? But at the end of the day, you'll be seeing that I'm able to get a value between 0 to 1. I'm able to transform the value of Z between 0 to 1 on both the cases. But here, what is changing? Over here, threshold value is changing, because here the threshold is nothing but it is 0.5, right? So I hope you're getting an idea about why do we apply an activation function, because to solve any binary classification problem, in short, right? So we cannot just keep it like this, but we really need to apply an activation function on top of it. So these are the two basic operations that we get. So after this, whatever output we get, right? Let's say whatever output we are getting, let's say I'm passing this 95.3. Okay, I initialize some weights. This will get multiplied. Then an activation function will get applied. And let's say that I got the output after this is somewhere around, let's say I got it as 0, right? If I'm getting the 0 for the first record, my real output is also 0. Then that basically means my error is 0. If my error is 0, then the weight that is initialized is very good. But let's say if my error is a little bit high, if my error is 1, then 1 minus 0 is 1, right? So over here, this is my real output for the first record, but I'm getting 1. So what I need to do? I need to update this weights, right? So this error that is getting created, I need to reduce it. So what will happen? We have to update this W1 and W2, right? And this process will continuously go on unless and until we get a suitable weights which will be satisfied for all these particular records and will give us a better accuracy with respect to this particular data, right? So these are the basic operations that we have actually performed. Now let me go back again and show you the step 1 operation is very simple. We have applied a z, which is nothing but summation of w of I x of I plus b, right? Now see, if I probably extend this from I is equal to 1 to n, let's consider that I have n inputs, then how will this operation look like? w1 x1 plus w2 x2 plus w3 x3, right? Plus like this up to wn xn. And then I have a bias added, right? Bias added. This equation is similar to the equation that we have with respect to y is equal to mx plus c. In y, we also, if you know linear regression, we also write something like this: beta 1 x1 plus beta 2 x2 plus beta 3 x3, right? Like this up to beta n xn. These two are almost same, and we are trying to solve this. And this is basically used to solve a linear problem statement, right? Linear problem statement. Now, what we are able to do with this to step 1 and step 2, let's say if I have a classification problem where I have 2 points like this, where I have 2 specific points like this, then with the help of Perceptron, what we are able to do? We are basically able to create a linear line which will be able to separate both the specific points, right? That basically means Perceptron is a linear classifier, right? Linear classifier, and that is what we are able to do with the combination of step 1 and step 2. At the end of the day, I need to find out the best fit line to solve a classification problem, right? So this was about a perceptron, and I hope you got an idea about what exactly is input layer, hidden layer, weights, activation function. And like this, there are many activation function, and each and every activation function has some different functionalities at the end of the day, right? So we will try to understand this more in depth from the next video itself, because we'll try to understand what are the advantages and disadvantages of perceptron, right? So this we will try to discuss in the next video, and then we will go from the single neural network to the multi-neural network, and then we'll try to understand that how does neural network actually work, right? And then we'll try to get the entire grips and idea about it, right? So why single neural network will not be able to use this single neural network to solve complex problems, right? This error that we are also getting, right? We also say this as loss function, or if we take all the records by once, we basically say it as cost function, and we really need to update this weight by just going forward and backward, which we also say it as forward propagation and backward propagation. Anyhow, we will be discussing that in the multi-layered neural network. So I hope you like this particular video. This is just a beginning, guys. We are going to learn many things as we go ahead. So yes, I will see you all in the next video.